This is Domain and Range Continuous Function Notes for Unit 1, Advanced Algebra 2. We're going to talk about 3 different notations. We have inequality notation. That's where we have our minimum number, an inequality, our x or y value, another inequality, and then our max number. Notice here it says no infinities. When we are trying to determine which one from the graph, we'll see a couple things. So if it's going to be less than or equal to, we're going to either see a closed dot or a solid line. And if it is just less than, then we'll see either an open dot, a dotted line, or an infinity, meaning that we have an arrow on our graph that is going towards either positive or negative infinity. The next one we have is set builder notation. Set builder notation takes the variable, so let's say in this case x, and then it does a vertical bar that stands for such that. And then just like the inequality notation, we have our minimum number, our inequality, our variable, our inequality, and our maximum number. So we would read this as, if we're using x such that x is between this minimum number and this maximum number. And then lastly, we have interval notation. Interval notation, we will use the parentheses or the brackets. So if we are using a parenthesis, we are following the same rules in inequality notation, where if we have an open circle, a dotted line, or an infinity, that means it's not included, so we use the parentheses. If we have a value that is included, meaning we would use the less than or equal to symbol, it would be a closed dot or a solid line, and that would make us choose brackets, because brackets means it is included. So let's go ahead and look at some examples. So in example 1, it wants us to find the domain and range, but in 2 different notations, using interval notation and set builder notation. So remember, when we're looking at the domain, we're looking at the value that is the most left and the value that is the most right. Okay, so the most left, the graph goes all the way here, and then the most right, the graph stops here. So those are going to be our 2 values that we're writing for the domain. So we have -5 to -1. Then to decide whether we're using the parenthesis or the bracket, we look at these open and closed circles at either end. So on the -5, we have an open circle, so that tells us we're going to use a parenthesis. But on the -1, we have a closed circle, which tells us we're going to use a bracket. Okay. And then I'm going to skip down to set builder notation, because once we have our interval notation, it's very easy to write set builder. So remember, we're dealing with domain, which is x, so we always start with x such that, and then we put our numbers in there. So we have a -5, I'm going to leave some space, -1. We know our x is between those 2 numbers, and then to determine if we're using less than or equal to depends on the parenthesis or the bracket. So since there's a parenthesis on a -5, we're going to be using less than, because that means it's not included. And then on the -1, we have a bracket, so we're going to use less than or equal to, which means that value of -1 is included. Now we're going to do the same thing for range. So for range, instead of looking left to right, we're going to look bottom to top. So our minimum value is right there at that -4. And our maximum value, how high the graph goes, stops there at 5. So we have our values. Okay, so we have -4 and 5. Okay, and notice how I'm always putting my smallest number first. Okay, then I go back and look at my graph. So on the -4, right here, notice that I have a solid line. That solid line tells me that I am going to use a bracket. And then looking at the 5 right here, as how far up it goes, notice that I have a open circle. So I'm going to be using a parenthesis. So looking back at set builder notation, now I'm dealing with y's. So I'm going to write y such that, I'm going to write my numbers in there. So -4 and 5, and I know that my y is between both of them. So since I have a bracket on the -4, I'm going to do less than or equal to. And since I have a parenthesis on the 5, then I just do less than. Okay. Now that I completed both of my notations, I am going to evaluate these at the bottom. So this first one is f of -2. So that means that that -2 is an x value. So we need to find that x value of -2 on the graph. So if I look at the graph, -2 on my x value is right here. So now I need to go either up or down to hit my graph. And so in this case, I'm going to go down to hit my graph at -4. So that means that my answer here is f of -2 equals -4. But since we're dealing with a graph, we have to write our answer as a point. So -2, -4 is my answer. Okay. So now I'm going to evaluate f of -5. So again, that -5 is an x value. So I'm going to go up here. I'm going to find my -5 on the x's, so right here. And then again, I need to go either up or down to meet my graph. So in this case, I'm going to go up. But notice that when I hit my graph, I hit it at an open circle at 5. So my answer is not including that 5. So since it's an open circle, my -5 does not exist. So down here, I would write f of -5 does not exist. DNE, does not exist. And that would be my answer. Let's look at number 2. Okay, number 2, notice that instead of our closed dot, open dot, we now have arrows that will indicate that the function is either going to infinity or -infinity. So starting with our domain, so again, starting from our left to our right, notice that if I'm just looking at the graph, it looks like the graph stops here and stops here. Okay, but I have to look at the graph again and make sure where I drew those lines, there's not any arrows. And since we have arrows here, I cannot determine if this function is going to stay within those lines that I drew. Technically, this function could be going out in this direction and it could be going out in this direction, meaning my domain could be going from -infinity to +infinity. -infinity to +infinity. And notice how I did not ask which one was going to go on the infinities, either the parentheses or the brackets, because we cannot include infinity, so we have to use the parentheses. Another way to think about it is, can you count to infinity? Okay, you cannot count to infinity, meaning you can't just stop at infinity and say, yes, that number is included. So we have to use the parenthesis. Okay. When we write that in set builder notation, another way to say -infinity to +infinity is saying all real numbers. So we would write that as x such that x belongs to all real numbers. This symbol here means belongs to, and this here is all real numbers. Okay. So now looking at the range, we're looking from bottom to top. So right here, it looks like this is as far down as it goes. And if we're just looking at the graph, it looks like it goes all the way to the 6 up here. But again, since we have those arrows, we can't assume that it stops there. So it's going to go on forever. So we are going to start at the y value 0. And then we're going to go on forever in the positive direction, so that's infinity. Remember, when we see an infinity or a negative infinity, we have to do the parenthesis. And then since that 0, if we look at our function closer, is crossing at solid lines here, then it's going to be a bracket. So this is telling us that our range is all numbers bigger than 0. Okay? So another way to write all numbers bigger than 0 is y such that y is greater than or equal to 0. All numbers bigger than 0. Now we're going to evaluate f of -1 and f of 0. So remember, these values in the parentheses are x values. So I'm going to find -1 on the x's. And I need to go either up or down to meet my function. So in this case, I got to go up. And I'm going to meet my function, looks like 5. Okay. Notice that there's a solid line there, so that means my value is included. So I'm going to write f of -1 equals 5. But my true answer is the point -1, 5. I have to always write my answer as a point since we are dealing with graphs. Okay, then I'm going to go back up and I'm going to find 0. So 0 on the x's, which means I need to go up or down to meet my point, my function. Notice I can only go up and I hit that function at 3. And again, it's a solid line, so I can write f of 0 equals 3, which is the point 0, 3. Let's look at number 3. Now on number 3, notice how we have a point, we have that open dot, and we have an arrow, okay? So starting with the domain, remember we're looking from left to right, so it looks like right here to the left, and if we were just looking at the graph, it would look like here to the right. But since we have that arrow, we can't assume that it stops there, so it's going to keep going in the positive direction. Okay, so looking at the point to the left, it looks like it's between -2 and -3. So I'm going to say -2.5. And then since I said it can't stop, or we can't determine if it stops at that 2 on the x's, with that arrow, it means it's going to infinity. Okay? And since I have an open dot on the -2.5, it's going to be parentheses on both. Okay? So this is saying that my domain is all numbers bigger than -2.5. So x such that x is greater than -2.5. Now looking at our range, so I'm going bottom to top. Looks like the same thing's happening. If I look at the top, it looks like it might stop at 6, but since I have that arrow, then I can assume that it's going to get larger than 6. So it's going to go to infinity. And then again, it's stopping on the bottom at about -2.5 again. So I'm going to write -2.5 in infinity. And since, again, there is that open circle there, it's going to be parentheses for both. So this is saying all numbers bigger than -2.5. So y such that y is greater than -2.5. Okay, now to evaluate, we're going to look at f of negative 2.5. So our x value of negative 2.5, which is right here. Notice I have to go down to meet my function, but I meet my function at an open circle. That open circle tells me that that negative 2.5 does not exist. So f of negative 2.5 equals DNE, does not exist. Okay. Now looking at this one, f of 1, I need to find 1 on my x's. So let's see, right here. And then notice that I don't need to go either up or down because when I write that negative 1, it already touches the function. So that means when f of 1, where x is 1, our y value is 0. So that means f of 1 equals 0, or we have the point 1, comma 0. Okay. Let's look at number 4. Number 4, notice again that we have arrows on both sides. Those arrows are going to tell us that we are most likely going to have a negative infinity and a positive infinity. So looking at the domain from left to right, if we just look at this graph, it looks like it stops and starts at negative 6 and positive 6. But since we have those arrows, we cannot determine that it stops there. So that means it's going to keep going on forever and ever. So that means we have the domain negative infinity to positive infinity. And remember, another way to say negative infinity to positive infinity, if we're writing it in set builder notation, is writing x such that x belongs to all real numbers. We're going to do the same thing for range, but we're looking bottom to top, so looks like about here to here. But again, those arrows tell us that they could eventually go past those green lines that I drew on the restriction. So it's going to keep going on forever in both directions. So that means just like the domain, our range is also negative infinity to positive infinity. And another way to write that in set builder notation is saying y such that y belongs to all real numbers. Okay. Now we need to find f of 2. So I'm going to find 2 on our x's. So here's 2 on our x's. And notice I have to go up to hit my graph, and I hit my graph at about 2.5 because it's between the 2 and the 3. So I am going to say f of 2 is approximately 2.5, or I can say that it's approximately the point 2, 2.5. Those little squiggles mean approximately. Now, checking f of negative 1, I'm going to find negative 1 on my x's. And then notice I have to go down to hit that point. I hit that point at a solid line at negative 2. So my answer is f of negative 1 equals negative 2. So I have the point negative 1, comma negative 2. Let's look at number 5. Okay. Number 5, our function here, or I should say our relation here is a circle. I can't say function because we know that if we were to do the vertical line test on a circle, that this would not be a function because it would cross at more than one point, okay? Which means there's going to be points on here that share an x value, and that's going to be important when we're evaluating at the end of this example. So first, looking at the domain, we're still looking at the restriction from left to right. So from left to right, it looks like we go from negative 6 to positive 4. Since it hits at a solid line, they are going to be brackets. So bracket negative 6, comma 4, bracket. So if I was to say this in words for our set builder notation, that means our domain are all numbers between negative 6 and 4. So x such that -6 is less than or equal to x, less than or equal to 4. X is between those two numbers, and they are included because they are solid lines. Now let's look at our range. So bottom looks about -7 and top is 3. So we have -7 to 3, and again, it's on a solid line, so they're included. So -7 to 3, both brackets. And so our y value is between those two numbers. So y such that -7 less than or equal to y less than or equal to 3. Okay. Now we have to evaluate f of -2. So we need to find -2 on the x's. And remember I said since this is not a function, we are going to have to share some x value. So notice not only can I go up, and I can also go down. So when I go up, I hit it at about 2.9. And when I go down, I hit that graph at about -6.9. So I have two approximations here. So I have f of -2 is approximately 2.9, and f of -2 is approximately -6.9. Okay, so again, if I was to change those to points, they would be approximate points because we don't know the exact values there. Now we have to find which values of x give f of x equal to -2. So this is the first time here that we are not finding that number on the x's. We are now finding that number on the y's. So -2 is right here on the y's, and I need to find the corresponding x value. So that means I have to go left and right. So if I go right, I hit it at 4, but if I go left, I hit it at -6. So I'm going to have 2 points here. I'm going to have x is equal to 4, and x is equal to -6, which means I have 2 points, 4, comma, -2, and -6, comma, -2. Okay, so we have 2 more examples here, and on these examples, we need to graph our function with the given linear function and the given domain. Okay, so before we do anything, we need to first graph that linear function. So we could do one of two things. We could create a table, and when we create this table, we can make sure we are staying within the domain of -2 and 8. Or another way is we could graph this function. So graph our y equals mx plus b by first plotting our b value and then doing our slope. Okay, so either method would work. I'm going to go ahead and do the method I mentioned last, and then I'll show you how we will do the restrictions on the domain. So remember, y equals mx plus b, where m is your slope, so your rise over run, and b is your y-intercept. So in our case, we have the y-intercept of -5 and our slope of 1/4, meaning up 1, right 4. So I'm first going to plot my -5. So here's my -5, and then I'm going to do my slope, up 1, right 4. So up 1, right 4, up 1, right 4, 1, 2, 3, 4. And then I'm going to do the opposite direction, okay? Down 1, left 4, down 1, left 4. Okay. So this right here is my line, but this is my line without following any restrictions. So if I look at my domain here, I have the restriction that it's going to include -2. So I'm going to go here and I'm going to change the color of my pen. It's going to include -2, which is about right here. And I'm going to do a solid dot because it's including it with that bracket. And then it's going to go all the way to 8, but it's not going to include the 8, so I have an open circle. Okay, so what I did in black is my answer. Okay, so I did my line, and then after I did that, I created my restriction. Okay. On number 7, I'm going to show you the other method. So the other method for this is to create a XY table. And on this XY table, we are going to only put X values that fall within our domain. So in this case, our domain is negative infinity to 6. So I can choose numbers 6, 5, 4, 3, 2, and I could keep going down all the way into the negative numbers. I could pick 0, negative 10, negative 20, but I'm just picking those numbers to guarantee that they fit on my graph here. So then I'm going to take those X values and I'm going to plug them in to find a Y value. So I would have negative 3 times 6 plus 1, which gives me negative 17. So notice how I plugged in the 6 into my function. Doing the same thing with the rest. Negative 3 times 5 plus 1 gives me negative 14. Negative 3 times 4 plus 1 gives me negative 11. Negative 3 times 3 plus 1 gives me negative 8. And negative 3 times 2 plus 1 gives me negative 5. So again, I plugged in all the X values that I chose to find my corresponding Y values. And from there, I have points. So I have the point, let me write this in a different color. I have the point 6, negative 17, 5, negative 14, 4, negative 11, 3, negative 8, and 2, negative 5. So I'm going to plot those points. So I have 6, negative 17. I have 5, negative 14. I have 4, negative 11. I have 3, negative 8. And I have 2, negative 5. Okay. Notice on my 6, I have a parenthesis. So that means it is not included. So I'm going to have an open circle there. But then it goes all the way to negative infinity. So I can keep drawing this line all the way up, and then I have an arrow at the end. So that would be my function corresponding to that domain.